Hello friends, welcome to engineering tutorial. So in the previous videos we have discussed about the electric dipole, starting from the basic introductory concepts about electric dipole and about the electric field due to the dipole along the axial and equatorial lines, and we have derived the whole mathematical expression for it. So in this video we are going to discuss about another concept associated with electric dipole, which is the torque produced by the dipole when it is placed in a uniform electric field. Okay, so this is a new concept. So let us just brush up a few things. So we have already discussed that, but still, the electric dipole, which is a system of two equal and opposite charges, two charges which are equal in magnitude but opposite in sign, separated by a certain distance. Okay, and the distance here is generally expressed as even multiple or multiple of 2, which is 2a, and these are the two equal magnitude charges with opposite signs. And another important thing is the dipole moment, which is the measure of the strength of the electric dipole, and it is given by the product of the magnitude of either charge multiplied with the separation distance, and it is a vector quantity. Okay, now let us say that this electric dipole, okay, this electric dipole minus q and plus q, it is placed in an uniform electric field. These are the electric field lines. Okay, so here here the length of the dipole, which is AB, this makes an angle theta with the electric field lines. Okay, so this makes an angle theta with the electric field lines. Now, so this is the dipole which makes an angle theta in the direction of the field. Now, the force acting on the positive charge, okay, plus q, it will be simply F vector is equal to q into E vector. We know that electric field is simply F vector by q. We have already discussed that the electric field is the force, magnitude of the force exerted on the positive test charge divided by the magnitude of the charge. So by that concept, by that formula, the force will simply be charge multiplied with the electric field. So for the positive charge, the force on the charge is given by q E vector along the direction of the electric field. Okay, for the positive charge. For the negative charge, minus q, this force will be negative minus QE vector, or we can say that its magnitude is QE vector but the direction is opposite to that of the electric field. Okay, opposite direction. So here this rotating force is in towards the right side, here it is towards the left side. So it will constitute a couple. Okay, these are two equal and opposite parallel forces which constitutes a couple and rotates the dipole in clockwise direction. Okay, and it rotates the dipole as long as the dipole is aligned in the direction of the electric field. Okay, dipole is aligned in the direction of the electric field. Now, what will be the torque on the dipole? Now we know that the magnitude of the torque is simply given by, the formula is force into the perpendicular distance from the point of impact or the point of application of the force, which is called as the arm of the couple. Okay, so here if we see, here is the force which is being applied, okay, here, and this is the arm of the couple, the perpendicular distance. So this here, this simply means F into BC. F into BC. Okay, let's just simplify it. C. Here, the force is acting in this direction. Here, the force is acting in this direction, and this BC is the arm of the couple. We have just simplified this diagram. Here, the force is acting in this direction, and BC is the perpendicular distance. Okay, so this is called as the torque. Force into BC, F into BC. So this will simply be, here BC is simply AB sine theta, okay, which is equal to 2A sine theta. 2A sine theta. F is equal to QE, BC is equal to 2A sine theta or AB sine theta. Sine theta is equal to perpendicular by hypotenuse. Okay, sine theta is equal to BC by AB. Okay, sine theta is equal to BC by AB, or BC is equal to AB sine theta or 2A sine theta. So here this is equal to QE into 2A sine theta. Now we know that Q into 2A is called as the dipole moment. Okay, Q into 2A is called as the dipole moment. So if we bring these two terms together, Q and 2A, Q into 2A will be P, and remaining E sine theta will remain as it is. So torque can be written as PE sine theta, where P is the dipole moment. Or we can write it in vector form as the cross product of the dipole moment vector and the electric field vector. Okay, so this is the expression of the torque on the electric dipole kept in an electric field. Now here this angle comes into play, so there will be different cases. For different values of this angle, the torque will be different. So when theta is equal to 0, we know that sine 0 is equal to 0, so the torque will be 0. It is called as the stable equilibrium state of the dipole. When theta is equal to 90 degree, we know sine 90 degree is equal to 1. In that case, the torque on the dipole will be maximum. Okay, so that tau max is equal to P sine 90 degree, which is equal to PE. Okay, so this is the concept of torque acting on an electric dipole placed in a uniform electric field. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.